All right. So this is number 42 on your last homework. Okay. We have this as pi over 6 and this side as 72.6. So what we want to do is, again, when I see a pi over 6, my mind just goes, I want to convert that. Okay, I want to convert that into degrees because right now we're more comfortable with degrees. Our conversion rate is pi equals 180. Okay. Or if you guys remember this would be awesome. Okay, 0 degrees equals 0 radians. That's easy. 30 degrees is pi over 6. Okay. 45 degrees is pi over 4. 60 degrees is pi over 3. And then 90 degrees is pi over 2. Okay? So just remember this, and then 180 degrees, if you guys want, equals pi. Okay? If you guys remember this table, it will serve you well. Okay? Because these are all the key degree measures that we do with the special right triangles. And in trig, without a calculator, right, I can require you guys to give me the sine of 30 or the sine of 45 or any trig function of these values. Okay? So we know that's pi over 6, and pi over 6 is already a special one, right? Equals 30 degrees. So this is 30 degrees. So this must be 60 degrees, correct? Yeah, because we have a 30, 60, 90 triangle. So remember, if we have a 30, 60, 90 triangle, we went over this little 30, 60, 90 triangle like that, right? And across the 30 is 1. Across the 60 is square root of 3. Across the 90 is 2. Right? I'm just going to put a variable here because any multiple of this 1, rad 3, and 2 is also going to be a special right triangle. Okay? So across the 60 is 72.6, correct? So this is 72.6, right? Across the 90th side, we need to get, I'm just going to put up another variable, x, and across the 30, we need to get y. Okay? And I just picked a random variable, right? You guys can pick whatever you guys want. So since a rad 3 equals 72.6, right? Now I know that these guys are equal to each other, right? So a square root of 3 equals 72.6. I solve for a by dividing it by square root of 3 on both sides. Okay, and when that happens, a equals, I have no idea, so 72.6 divided by the square root of 3, 41.9. Okay, so my a value is 41.9. All right, 41.9. So that means my y value equals 41.9, right? And then look, across the 90 is going to be 2a, right? We have that so far. So if a equals 41.9, 2a equals 83.8. Just multiply 41.9 by 2. Okay? So that is 83.8. All right? Okay. Questions on that? No? Pretty simple, right? And if I require you to put this 60 degrees into radian form, right? Then just convert it back, okay? So we converted it to 60 degrees because we know that that's 30. That's easy math. But 60 degrees, again, is special, is pi over 3. So that is pi over 3. All right? Cool. Questions on that? And 42, right? Or that was 42, 44. 44. Okay, so number 44, we have this right triangle. And excuse my drawing. 420, 425. And then this angle here is 3 pi over 8. Okay? Okay. So if you guys remember that list, right, over 8, the denominator being over 8 is not a special one. Okay? It's not going to be a special one. So we got to convert it using our conversion rate. So 3 pi over 8 times, I want to get rid of my radians, so pi, and then 180, I want degrees, right? So right off the bat, these pi's cancel out. Okay? All right. So if we do this math, the 180 and the 8 cancels out by what, 4? 180 divided by 4 is 45. 8 divided by 4 is 2. So this is 3 times 45 over 2. Okay? So if we do that, this would be 135 over 2, which is 67.5. Okay? So this angle here is 67.5 degrees. Okay? If that angle is 67.5, then this angle here must be 90 minus 67.5, right? Right, 180 minus 90, which is 90, minus 67.5, which is 22.5. Okay, so we got that as our degrees, right? We're good with that. Move this. So now we have to use our trig function, okay? Because we cannot use our special right triangles because 22.5 is not anything special, or 67.5 is nothing special, right? There's no 22.5, 67.5, 90 triangle. So I am going to use 22.5 as my reference angle, and we're going to learn more about that word in a little bit. So looking at from this angle, we have this as my opposite side, this side as my adjacent side, and 425 as my hypotenuse, correct? So if I wanted to solve for my opposite side, and I have my hypotenuse, what trig function deals with opposite and hypotenuse? Sine, right? So the sine of 22.5 equals opposite O over 425H. Correct? Yeah. So before I even touch my calculator and get the sign of 222.5, I'm going to solve for O. Okay? In order for me to solve for O, I'm going to multiply by 425 on both sides. Right? That will cancel that out. So I have O on one side, and I have 425 times sine of 22.5. Correct? Yeah. So if I put that on my calculator, 425 times the sine of, make sure your calculator is in degrees. Okay, make sure your calculator is in degrees. And if you do that, it's 162.6. My opposite side is 162.6. Okay? This side here, oops, is 162.6. Okay? And now from here, class, we can go one of two directions. Okay? One of two ways to solve this. We could either A, use 425, use 162.6, use the Pythagorean theorem to figure out my last side, right? A squared plus B squared equals C squared. Or we could just use trig again, okay? I leave that up to you. Whatever you guys want to do, whatever feels more comfortable. You guys want me to show you guys both? Just so that you guys have both options, okay? So using Pythagorean theorem first, A squared plus B squared equals C squared. That'll be 162.6 squared plus B squared equals 425 squared. And you guys might be wondering, why did I label this as my A and this as my C, right? As long as the longest side, right, which is across the 90, your hypotenuse, is your C, your A and your B doesn't really matter, okay? As long as the 425 is your C squared, then the other two sides doesn't really matter, okay? So here I have 425 squared. I am using my calculator, which is this big number. Oh, you know what? Sorry. Before I even touch my calculator, right, I'm going to solve for B. Okay? I'm going to subtract 162.6 squared. Subtract 162.6 squared. That is B squared equals 425 squared minus 162.6 squared. Right? And then now the numbers are getting really ridiculously big. So I'm going to just do this math here. And I get this big number there, right? Yeah, I'm not going to write that number down. I don't require you guys to write it down just because it's just calculator work. And then I'm going to square root it. Right? So B equals this whole thing. I'm not going to rewrite it and waste your time. Okay? So square root that answer. Okay? Which is 392.67. Okay? 392.67 or 392.7. So B equals 392.7. Okay? Approximately. So remember, when it's approximate, you guys use these little wavy lines. All right? Okay? Dave, can you do me a favor and then turn off these lights here? Just because the glare. The whiteboard, yeah. Okay. Now, the other way to use it, the other way to do this is to use trig. Okay? So I have my hypotenuse again, and I use my hypotenuse again because that's a cleaner number than 162.6, right? So I'm going to use my hypotenuse. I'm going to use my adjacent to figure out what my adjacent side is. So what deals with A and H? What trig function deals with A and H? Cosine. So the cosine of 22.5 equals adjacent A over 425, which is my hypotenuse. Again, multiplying both sides by 425. Okay, to get rid of this, that is A equals 425 times cosine of 22.5. All right. Honestly, class, if um, I you cannot use your calculator, right, on an assessment or a quiz or whatever I give you guys, yeah, I would not require you guys to do anything else besides this. This would be your answer. Okay? This would be it. All right? Or it would be, or this, if you guys use the Pythagorean theorem. Does that make sense? Yeah? I would not require you guys to figure that out going into your brain and trying to do 425 squared, right? We're not going to waste time. I know you guys can do it. This is pre-cal, so you guys should be good. Yes. What'd you get? Yeah. Okay. So 425 times cosine of 22.5, that is 392.6, right? Or 392.7. Okay. All right. Cool. So when it says to solve the triangle, that's what you need to do. Okay. Last thing before we're through with this one. You see how 22.5 is a degree measure, right? And if I do require you guys to put that into radians, you could turn that back into radians one of two ways, okay? You can multiply it by our conversion rate, degrees. I need my radians, which is 180 degrees, right? You guys can do that, which if you guys do 180 divided by 22.5 is 8, yeah? So 22.5 goes into 180 8 times, which is pi over 8, okay? You guys can use the old conversion rate. Or what is 90 degrees in terms of 90 degrees in terms of radians? What is 90 degrees? Huh? Pi over 2, right? Yeah. I know that 3 pi over 8 plus this question mark angle is going to equal pi over 2. It's going to equal 90 degrees, right? So pi over 2 minus 3 pi over 8. What is that math? We need the same denominator, correct? 8. So 8. This would be 4 pi over 8 minus 3 pi over 8, which is pi over 8. Yeah? Yeah. All right? So you guys can use whatever one that you guys want. All right? There are multiple ways of solving a right triangle. Okay? Questions? No? All right. So that's your homework. I believe that is due today. Did you today? Okay. So today what we're gonna do is we're gonna. Can you guys still hear me? What we're gonna do is we are going to jump into our next section, which is 6.3. Okay, and what we're gonna be talking about is reference angles, and we're gonna just go. Okay. So this is 6.3. You go down to that section in the book. Okay, went too far. Okay, so you guys see this triangle here, right? The triangle that we've been working on. This is my theta. Okay. And if this is my theta, this will always be my hypotenuse, correct? Yeah. This angle, this side here is my opposite side. Okay. And this side here is my adjacent side. Correct? Yeah. Okay. Now what I'm gonna do, you guys see I made like an XY graph, right? A coordinate plane. I'm gonna take this triangle, literally take it, and put it on here. Okay? So when I do that, this is gonna be my vertex of this angle here. It's gonna look something like that, right? Yeah. Makes sense? We've talked about this angle too, right? And we've talked about this being my angle measure, correct? I believe in our last section we did, right? For example, if we have, let me just take this, right? If I wanted to graph, I don't know, an angle of 35 degrees, we would make this my XY and then go positive 35 degrees, right? With this side being my initial side and this side being my terminal side. Yeah, that's what we went over. Okay. But now we're going to turn that angle into a triangle. Okay. And this is my theta. Okay. Now, now that it's on a coordinate plane, right? This point here is on my coordinate plane of x comma y. Correct? Yeah. Let's just come up with an example. Let's say x is 4 and y is 3. Okay? 4 comma 3. If I asked you to graph 4 comma 3, that point would be here, correct? Yeah. Well, from our origin, if I asked you to graph, what you would do, and you guys already know this, but you guys don't know this, don't know that you guys know this, so your brains would be blown away. 1, 2, 3, 4, correct? And then 1, 2, 3, right? So if I asked you to graph 4 comma 3, you would go 1, 2, 3, 4, and then go up 3, correct? So this is actually 4 in this example, and this is actually 3, right? 4 is my x, 3 is my y, right? Now let's compare this triangle with this triangle. Okay? Here, my adjacent side is my x. Okay? So instead of saying adjacent, I'm going to say x. So x equals adjacent. Okay. And then here, my opposite side became my y, right? So instead of saying opposite, I'm going to say y. Okay? Make sense? Yeah? Now, what in the world is my hypotenuse? There must be something here. What is this side referring to? Okay, what is this side here? Huh? That is my terminal side, yes, but it's not called my terminal side. What is that? Huh? Z? No, we're not getting into calculus here. We're not gonna go into a Z is actually a 3D type of coordinate plane, which we're not gonna get into. But good try. What do you guys think it is? We're figuring out this side here. What is the basically the equivalent of my hypotenuse in this triangle? Huh? Uh, the slope of the line? Yeah, but then that doesn't tell me the length of it, does it? It tells me the slope of it, right? The radius. It's a circle, right? That was gonna be my hint before he answered. Huh? It's a circle because I'm not gonna try and draw it because I'm gonna mess it up. Okay? Yeah. But if I take let's see if I can draw it. I'm gonna try and draw it in pencil. Let's take this as my radius, right? It's gonna go off the chart, but you guys see how that's gonna be like a circle? Yeah, it's gonna be a messed up circle because I can't draw. But you guys see how that's gonna be the radius? That's every single time. Okay? Your hypotenuse is your radius now. Okay? Alright? So using x, y, and r instead of adjacent, opposite, and hypotenuse, I know you guys can do this. Okay, so I'm just gonna give you guys some time to get my new trig functions. For example, sine is opposite over hypotenuse, so it's gonna be y over r. Yeah? Opposite over hypotenuse, which equals y over r. Okay? So take some time to do this. Give you guys a little 30-second head start. All right? I'm going to quietly fill this out. Okay? Yes, it would.
Okay. So then that is your new trig functions. Okay. We're graduating from opposite adjacent hypotenuse to x, y, and r. All right. Okay. All right. So now, just like before, where we got our opposite adjacent hypotenuse triangle and we plopped it onto our xy, right, graph, xy coordinate plane. Since the coordinate plane has 4 quadrants, we are going to be drawing our reference triangles in that quadrant. Okay? So our first one in quadrant 1, this is quadrant 1, is this triangle here, where this is my theta. Okay? All right. In our quadrant 2, which is this quadrant here, if my angle, class, let's say is like that, right? And I say that this is my initial, right? Because it's always going to be that positive x-axis as my initial side. And I say that this is my reference or my terminal side. And this being, let's say, 135 degrees. Correct? I'm kind of jumping the gun, but I feel like you guys are ready. My reference triangle, right, will always be created. Always, always, always be created by, oh, that's too close. By picking a random point on my terminal side. Doesn't matter. Yeah. And making that perpendicular distance or perpendicular segment from the terminal side to my x-axis. It'll always be that way. Terminal side to my x-axis. Okay? That perpendicular distance to make that right triangle. All right? And you guys see that right triangle here, right? So then this angle here is my theta. And we're going to come back to this in a little bit. Okay? We're going to be talking about my reference angle. So this, class, is my reference angle. Okay? I want to put here, up here. Oops. But you guys can't see it. I want to put up there. Theta equals my reference angle. Okay? That make sense? Okay. Let's go move on to my third. Let's move on to my third here. This one. My third quadrant, which is this quadrant here. Okay. That reference angle, this is going to be my terminal side again, right? This is my initial side. That's my terminal side. My reference triangle is always going to be created. Pick a random point on the terminal side. Make the perpendicular distance or perpendicular segment to the positive x-axis. Okay? It's always going to be the always going to be the x-axis. Not the positive x-axis, but the x-axis. Okay? Okay, so that's my reference triangle. Therefore, making this my theta or my reference angle. Okay? And then my fourth and final one This is not 3, but this is 4. Fourth angle is here. Fourth quadrant is here. Okay, and again, I made it with my x-axis, right? Okay, this is my terminal side of this angle there. But my reference angle is here because that is a part of my, okay? Okay, so there's a bunch of triangles if you kind of think about the coordinate plane, okay, that we're going to be dealing with. All right? Okay. Put it up. So, the next thing I have to do, since we have all of these reference triangles or these reference angles, right? And we're on a coordinate plane. If we're on a coordinate plane, then my x's and my y's in particular, right, become negative or positive, right? Positive or negative, correct? Depending on what quadrant I'm in. Yeah? Right? So for example, let's just take this coordinate plane for example. Okay? Here in quadrant 1, my x value is it positive or negative? Positive. My y value is positive, right? My r value here, class, that's a trick question because r is radius, correct? And that's a physical thing, correct? In a circle, the radius is from the center to the circle, correct? And that can never, ever, ever be negative, right? If it's negative, then you're in an alternate universe. That's always going to be positive. That make sense? Okay? So they're all positive in quadrant 1. Okay? So making all the trig functions positive. X over r, y over r, x over y, right? All the 6 trig functions are going to be positive, right? Because it's going to be positive over positive, yeah? No matter what trig function you're talking about, correct? Okay. In quadrant 2 here, my x is negative because I'm on my negative x-axis, right? But I'm in my positive y-axis, so that my y is positive. My r is always going to be positive, okay? What trig functions here are positive then? Let's go through the list. I don't want you guys to write it down because this is going to be a shortcut, but let's just go through it, okay? So here, sine is x or y over r, which is positive over positive, so that's positive, right? Cosine is x over r, which is negative over positive, which is negative. Tangent is x over, or is y over x, which is positive over negative, which is negative, right? And honestly, the reciprocals are going to have the same negatives and positives, right? I'm not going to go through all 6. I'm just going to go through these 3. Which one's positive here? Sine is. So sine is positive here. Okay, in my third quadrant, x, y, and r. Well, my x, I'm in my negative x-axis. So that's negative. Negative y-axis. So that's negative. My r is always positive, right? So let's go through this again. Sine, cosine, and tangent. Sine is y over r. Y over r, negative, positive. So that's negative. Cosine, x over r, negative over positive. So that's negative. Tangent, y over x, negative over negative, which is positive. Correct? So here, my tangent is positive. Okay? Quadrant 4, x, y, r. X is positive, y is negative, r is always positive. Everybody understand this? X, y, and r? Positives and negatives. Any question there? No? Okay. So you guys can see that x over r is going to be positive, right? Yeah. Or we can go through this again. Sine, cosine, tangent. And I'm not going to write out sine, which is y over r, negative over positive, which is negative. Cosine, do that. Cosine, which is x over r, positive over positive, which is positive. Tangent, y over x, negative over positive, which is negative, right? So cosine here is positive, right? So cosine is positive. So to sum up, I'm just going to get the first letters. A, all is positive. Sine is positive. Tangent is positive. And cosine is positive, right? All students take calculus. That's the original way to remember it. Yeah, going from quadrant to quadrant. Another way to remember it is ax, going clockwise. ACTS. Okay. The best way to remember this class is the activity that we just did. Okay. But if you guys do want a shorthand, all students take calculus. Yeah. I'm not going to try and make a funny one just because I'm recording this lesson. All right. Good. Okay, now we're finding reference angles, just like our theta. Okay, in our previous examples, we're trying to find theta. Okay, so here's your train of thought. If we have to find this reference angle, whenever I'm given an angle to find, my thing first off is I'm going to draw a coordinate plane. Okay, a small little one. It doesn't have to be perfect. All right. I'm going to draw that out. And 135 degrees then, starting from my initial side, always start off with your initial side, which is the positive x-axis. Okay? Going up, that's 90. So this is 135, right? Yeah? That's 135 degrees. So if that's 135 degrees, my reference angle or if you guys want to think about it, my reference triangle is going to be from the terminal side down to my x-axis, right? And the reference angle is always going to be this angle here, okay? That the right triangle that you just created has. It's going to be that angle. What is the degree of that angle? You guys just kind of do it intuitively, right? I know that this whole thing is, the straight line is 180. So 180 minus 135. 45 degrees. Yeah. So that reference angle is 45 degrees. Okay. And the cool thing about this class and how we're going to be doing this, we're going to be evaluating it on the bottom here. But the cool thing about this is that the trig functions, sine, cosine, tangent, cosine, and tangent, all 6 of them, of a 45 degree in quadrant 2 is the same thing as the 6 trig functions of 135 degrees. Okay? So sine, cosine, and tangent of 135 degrees. Does that make sense? Yeah, they're going to be equal to each other. Okay? And that's the end product of this lesson here. One of the end products. Okay? One of the skills that we're going to be learning. All right? But what about 5 pi over 3 here? What do you guys want to do with that 5 pi over 3? Turn it into degrees. Okay? Over 3 is what? I'm going to rewrite it as 5/3 pi. What? Oh, no, I'm sorry. I rewrote it. I wrote this wrong. I'm going to write it as 5 times pi over 3. Okay? What's pi over 3? 60? 45? 30? What is pi over 3? Can we say it confidently, more confidently? 60 degrees, right? Okay, not 60. Okay? So it's 5 times 60, which is 300 degrees. Okay? Once we get that, okay, let me draw it out really quick. And again, it doesn't have to be the nicest one. Okay? Start off with your initial side here. I know 300. I know that this is 270. We're going like that, right? That's 300 degrees. Yeah. So my reference angle is this guy here, which is 360 minus 60, or 360 minus 300, 60 degrees. Okay? That makes sense? Yeah? Remember, in my 4th quadrant, my x is positive, my y is negative, right? So the 6 trig functions will follow those signs. All right? That makes sense? Okay? All right. That's how you find the reference angle. Now let's evaluate. Let's get that angle measure, or let's get that trig function. Okay? Sine of 240. All right. It's in degrees, so I'm going to go straight into my xy coordinate plane. 240 that's my initial side. That's 180. That's 270. So it has to be in my 3rd quadrant, right? It doesn't have to be the perfect 240 degrees. Okay, as long as my terminal side is in my 3rd quadrant, you're good. Okay? So this guy is 240. So this angle here is 240 minus 180, which is a number. Don't use your calculator. 180, you need 20 to make 200. You have 40 more. 20 plus 40 is 60. Right? Oh. It's the middle of the day, guys. Your brain should be kind of firing right now. All right. All right. I want to let that one slide. Okay? So, class, in order for us to evaluate sine of 240, I need, so this is 60. I need that reference triangle, right? Pick any point along that terminal side, put it on my x-axis, right? That's my reference triangle. Now, let me ask you, if this is 60, this must be 30, correct? Yeah? What's the value of my sides? What's the value of this side here in a 30, 60, 90? The most reduced value. Oh, let's not jump there just yet. What's the value of this side across the 30? What's the ratio of the sides of a 30, 60, 90? A rad 3, and 2A, right? But the most reduced version, remember, is 1, rad 3, and 2, correct? You got those things, right? So across the 30 is 1, across the 60 is rad 3, across the 90 is 2, correct? But since I am in my third quadrant, which my x and my y are both negatives, this is negative and this is negative. Understand that? Yeah? So in order to get the sine of 240, that's going to equal the sine of 60 in my quadrant 3. The same thing, right? So if you get the sine of this triangle here, we get the sine of this 240. That make sense? Yeah? That's why they're called reference triangles and angles. Okay? Because we use these to figure out the bigger angle. So the sine of this, which is y over r, or if you're not sure because we just learned it, right, is opposite over hypotenuse. Yeah? Opposite, which is negative square root of 3 over hypotenuse, which is 2. Yeah? So this will be negative square root of 3 over 2. Make sense? Okay? Questions on that? How did I? Why did I? What did I? What's up? Okay. I thought it was math related. I'm sorry. Okay, we can go down this route. Okay. That's gross. Okay. Okay, coming back to math a little bit. 495. Okay? Yeah, 495. Trying to do okay. So 495 is obviously more than 360, right? Duh. Okay. So what I'm gonna do first is I'm gonna subtract that 495 by 360. Okay? Because I know I have to go run one rotation around. So I know that this angle is going to be one rotation around already. So if I do that, that's 135. Oh, I'm back to that 135 degrees. Okay? So that tangent, so 495 degrees is actually here in my second quadrant, right? Okay? So making a reference triangle, I have that, right? So this angle here, what is that angle there? This red angle, 45, right? We just did it like 3 examples ago, right? That's a 45, so this is a 45, so that's a 90, right? What is the most reduced version of that, the ratio of the sides? 1. Okay, I give you 1. 1, what is this one? 1, rad 2, right? Huh? Because then this is a 45, 45, 90. The question was, why is it rad 2? This is a 45, 45, 90. So I know that it's an isosceles triangle. In an isosceles triangle, the sides are equal, right? So if this is 1, this is 1. You use the Pythagorean theorem. 1 squared plus 1 squared is 1 plus 1, which is 2. Square root 2 is my hypotenuse. That's like the most simple way where you guys would understand it. Yeah? Okay? So 1, 1, rad 2. I'm trying to find my tangent, which is y over x. Or if you guys aren't used to that, but we just learned it, it's going to be opposite over adjacent, which is 1 over 1, which is just 1. Hold on. I know I made a... Yeah. Go ahead, Jay. Correct me. It should be negative 1, right? That should be negative because I'm in my negative x-axis, right? So negative or 1 over negative 1, which is negative 1. All right? Cool? There is going to be more, but let's just convert, do the same thing, right? Convert, do the same thing. All right? You guys understand that? I'll try this one out. Try to get this. I'm just going to quietly do it here. I want to give you guys another couple minutes head start. Okay? Can I? Erase it? Yeah. No, get the sign. It goes around 2 times. And then you have 240 left over, so it should be like here. Did we all get that? Yes? Yeah. Okay.
Oh wait, no, I did get. Oh wait.
Okay. So the question was, class, how did I convert it? Right? Basically, so quickly. Okay. Remember our first example here where we did the homework question? And I said that this would be beneficial, right? For you to kind of know or memorize. Okay. I use this, pi over 3. So whenever I see a denominator of 2, 3, 4, or 6, okay, I know that it's a special right angle or special angle. Okay. So since it's pi over 3, if I'm trying to get 16 pi over 3 and convert that into degrees, I notice how I rewrote it. 16 times pi over 3 is the same thing as 16 pi over 3, correct? The reason why I wrote it this way is because pi over 3 equals 60. So it'd just be 16 times 60, which would be 960, right? And then from here, well, 960 is obviously going to be more than 360. Hold on. So if it's more than 360 and 2 rotations around, it's going to be 720, right? So I just subtracted 960 by 2 times 360, which is 720, and got 240. 960 by 7, or yeah, by 720. Because I know that 960, this is 360, right? Let me use highlighter. I know that this is 360, right? I went one rotation. I went 2 rotations. That's where I stopped. And that's 720. And then 720 or 960 minus 720 is 240. So 240 is represented there. Okay, if you guys followed my highlighter. So, okay, so if this is 240, right? 240 minus 180 is 60. Remember, across the 60 is rad 3. Across the 30 is 1. Across the 90 is 2, right? And getting the sign is opposite over radius, or opposite over hypotenuse, or y over r, okay? All right? So the cotangent of, we're not going to do this today. I feel like you guys are done. The second half of the lesson. But trig identities. But yeah, the cotangent of pi over 4, that is, but look, going negative, right, is easy. Just go counterclockwise or go clockwise, right? What's pi over 4? A 45-degree angle. So if you extend that out, that's a 1, that's a 1, that's a rad 2, but this is negative because I'm on my 4th. Yeah.
cotangent is x over r, or x over y.